Welcome children to our next class. Today we will be doing like and unlike terms. So if you've understood the algebraic factors of each term properly, this won't be very difficult for you. So just see here, like and unlike terms. Now can you see the colored parts? I've colored some terms. Some of the colors are same. Now what do you observe from here? I've colored 7y and 3y same. I've colored minus 5x and 4x with the same color. I've colored 2x square and 3x square with the same color yellow. xy and 3xy with the same color. So if you observe, you'll find that the algebraic factors in blue are same. It's y. In xy and 3xy, can you see the algebraic factors? It's xy in both the cases. In 3x square and 2x square, algebraic factor is x and x. In minus 5x and 4x, we have algebraic factor x. So terms having the same algebraic factors are called like terms. So now what do you observe in the above circles? So we observe the circles having the same color, have the same algebraic factors, and hence they are called like terms. So I've given you the details. 7y, 3y are in blue color. They have the same algebraic factor y. Minus 5x and 4x within the red colors have the same algebraic factor x. Now what do you think are the numerical factors in the red colors, red circles? Minus 5 and 4, isn't it? For minus 5x, the numerical factor is minus 5. Algebraic factor is x. And for 4x, the numerical factor is 4 and the algebraic factor is x. So we observe that the algebraic factors are same, so they are called like terms. Similarly, we have the next one, see, minus 6xy, xy, 3xy. So these terms, minus 6xy, 3xy, xy, they have the same algebraic factors, xy. And hence, they are also called like terms. Then again, 2x square and 3x square, they have the same algebraic factor, x square. That is x into x. So they are also like terms. Like terms are important because for addition and subtraction, we need the like terms. We have to know which are the like and unlike terms. So I hope it's clear with your like terms. Next, we have the definition of the like term. Terms having the same algebraic factors are called like terms, and terms having different algebraic factors are called unlike terms. Now here there is a question from your text. State with the reasons whether the given pair of terms is like or unlike terms. So there are 11 questions here. And you know these, if you write in the form of a table, it becomes more easy for you to understand. It's a pair of terms. The first pair in the question, if you observe, it's 7x and 12y. These are two terms given. So I've written 7x and 12y, one below the other. These are the pair of terms for the first question. Then I find their factors. What are the factors? Numerical as well as algebraic factors I've written. So 7, x, 7 and x are the two factors here. 12 and y are the two factors here in this term. Isn't it? Now, algebraic factor. What is the algebraic factor here? Here it is x, here it is y. So they are not same. They are different. So they are what? 7x and 12y will be unlike terms. Okay. So the variables or the algebraic factors in the pairs are different. So here you have written the definition, you have written they are unlike, why unlike, you have written everything in this table form. The next question is minus 2xy and 3yx. So first I write the terms. Now the terms, can you see they are without commas, okay? This is a term, minus 2 into x into y. And this is 3 into y into x. So this is minus 2xy, this is 3yx. Now what are the factors here? Minus 2 is a factor, the numerical factor, x is a factor, y is a factor. Here also 3 is the numerical factor, y is a factor, x is a factor. So I wrote x first and y later on. You can do it this way. So what are the algebraic factors? I've written all the factors. So factors are same, algebraic factors are same. Numerical factors are different, it doesn't matter. But algebraic factors has to be same for like terms. So that's why I wrote same, like, and same variables. Why? Because xy is equal to yx. Because x into y is equal to y into x. You can say commutative property also. You can say x into y need two numbers when multiplied or added. In any order will give you the same. So similarly, it is with the variables. Whatever value you put for x and y, xy will be is equal to yx. The result will be the same. So we have to find out only the algebraic factors and check whether they are same for like and unlike terms. So to be like, algebraic factors has to be same, otherwise it is unlike terms. Okay. So is it clear to all of you? Try out each of the sums. Now, of course, in the question, I have included two constants also. First, you try to reason out and see what you can write about it. Okay, we'll discuss it later on. So, let's try to do it. Now we come towards the end. What are the things we learn? For like and unlike terms, we have to check the variables in the term. So whether it is x, y, z, p, q, whatever it is, a, b, c, we check the variables. And then next you check the powers of each variable in the term. Let's suppose there are two terms, 4x and minus 2x squared. So it won't be like terms because one is x squared. X is x to the power of 1 and x squared is x to the power of 2. So both are different. For x, your variable is x. For x squared, your variable is x into x, xx. X squared is x into x. So what are the variables you have? X and x, isn't it? So the powers are, if the powers are not same, then they will be unlike terms. So that's all for today.